September 8th, 2004. Utah Test and Training Range. Two helicopters are already in the air, engines running, waiting for something to fall out of the sky. Not a satellite. Not debris. A spacecraft deliberately aimed at this exact patch of desert. Carrying 3 years of work, NASA did not want touching the ground. The plan? A parachute opens high above the desert. Then a second, wider parafoil. Then one of these helicopters flies underneath it, hooks the parachute lines in midair, and carries the capsule down by hand. The capsule enters the atmosphere on schedule. The pilots watch the sky. The parachute does not open. The capsule tumbles and hits the desert floor at nearly 200 miles an hour. Rewind 3 years. Genesis had spent that time parked far past the moon, at a gravitational balance point between Earth and the Sun, doing one job: catching pieces of the Sun itself. Not chunks of rock. Solar wind, a thin stream of charged particles the Sun constantly sheds. Genesis caught them on ultra-pure collector panels, letting individual atoms bury themselves microns deep in the material. The idea: the Sun holds nearly all the mass in the solar system, so its makeup should be close to the original recipe everything else formed from. If Earth turned out even slightly different, that would prove something about planetary formation nothing else could. For 29 months, Genesis collected. Then it packed those particles into a return capsule and sent them home. That capsule is what had just hit the Utah desert at 200 miles an hour. Here is what was supposed to happen. As the capsule hits the atmosphere, it slows down hard, fast enough that the deceleration itself becomes a signal. A small mechanical switch inside the capsule is built to feel that exact force. A G switch. When it senses the capsule slowing, it closes a circuit. That circuit fires a small explosive charge, releasing a drogue parachute. A small chute meant to stabilize the capsule and slow it further. A few minutes later, at around 4 miles up, a second charge fires, cutting the drogue loose and pulling out the main parachute. A parafoil, wide enough for a helicopter to catch. Every step depends on the one before it, and the very first step, the one everything else waits for, is a switch sensing a force and closing a circuit. Now watch it again, knowing what to look for. The capsule enters the atmosphere. It slows down exactly as designed. This is the moment the G switch should close. Nothing happens, no charge fires, no drogue. The capsule keeps falling faster and begins to tumble. Nothing left to stabilize it. With no drogue to release, there's no signal to pull the main parachute either. One missing link breaks everything downstream of it. The capsule comes down under no control at all and hits the desert floor at 311 kilometers an hour. 193 miles an hour. Investigators pulled the surviving hardware apart to find out why. Inside the capsule's avionics unit, they found 2 G switches mounted on a small circuit board. Each one is built to sense deceleration in exactly one direction. The direction the capsule would actually be slowing in during entry. X-rays showed the switches sitting 180 degrees from where they needed to be, turned exactly backward. Whatever force was supposed to close that circuit would instead pull it further open. The obvious explanation: somebody put them in wrong. But investigators checked. They compared the physical hardware against the engineering drawing that specified how to build it. The switches matched the drawing exactly. The technicians had done their job. The drawing itself told them to install the switch backward. And nobody had caught it. That drawing wasn't created from scratch. Genesis's circuit board layout was copied from an earlier mission. Stardust, a sister spacecraft built to bring back comet dust, using a nearly identical landing system. Stardust's own drawing never marked which way the switch was supposed to face. No note, no arrow, nothing. Whoever copied that layout for Genesis had, in effect, a coin flip. Heritage hardware is supposed to lower risk, reuse what's already proven. Here, it just carried an old blind spot into a new spacecraft. There were 2 G switches on that board, not one. That sounds like a safety net. If one fails, the other catches it. It wasn't built that way. Both switches had to agree before anything would fire. A way to stop a single switch from triggering the parachute by accident, from vibration or electrical noise. Nothing would happen unless both said yes, but both switches came from the same board, built to the same backward drawing. If one was wrong, so was the other. By definition, not by chance. Investigators had a name for this: a common mode failure. Two supposedly independent systems sharing one hidden flaw, failing together at the exact same moment for the exact same reason. So how does an error like that survive years of engineering review, all the way to launch? Genesis's own test plan had an answer for this once. A centrifuge test, spin the hardware, recreate the real force of atmospheric entry, and watch whether the switches actually respond. Exactly the test built to catch a problem like this. It was on the schedule at the project's critical design review. Then the hardware fell 4 months behind. Schedules tightened, and somewhere below the level anyone senior was tracking, the centrifuge test was quietly dropped, replaced with a review of drawings and paperwork instead of hardware. No one signed off on that decision. No one flagged that it removed the one test built to catch exactly this kind of mistake. A smaller test was added later, a quick check that the switches made electrical contact at all. It passed, but it only proved the switches could conduct electricity. It never tested which way they were facing. The switch that failed was tested. Just never for the one thing that mattered. Genesis was also built in an era NASA itself called faster, better, cheaper. And the board's own report says as much, though only as a passing note, not a formal finding. Its strongest official conclusions point somewhere more specific. The missing sign-off, the missing test, the assumption that heritage hardware didn't need a second look. For the recovery team on the ground, the crash looked like a disaster with no upside. The capsule had cracked open. The science canister inside was breached too. Most of the ultra-pure collector material, the whole reason for the mission, had shattered, some of it into pieces smaller than a grain of sand. But not all of it. Roughly 15,000 fragments, each large enough to analyze, survived largely uncontaminated, protected just barely by the wreckage around them. Scientists spent months in a clean room, sorting pieces by hand. What they found justified the mission. Genesis measured the sun's own oxygen, and it didn't match Earth's. Not a small difference. Real, measurable evidence that our planet formed from different material than the sun itself did. A 3-year mission that ended in a 200-mile-an-hour crash still answered the question it was built to answer. The investigation's recommendations weren't really about one switch. They were about how confidently NASA can trust a drawing, a test plan, a piece of hardware labeled already proven. A design being internally consistent doesn't mean it's correct. A backup only protects you if it's actually independent of the thing it's backing up. And deleting a test doesn't just save time. It deletes the one chance to find out you were wrong. The clearest proof the lesson landed, Stardust, the very mission Genesis had borrowed its drawing from, was still in space, still inbound, its own landing still over a year away. Investigators flagged the same hardware on the same design, and Stardust's team went back and checked their own switches before they came home. Stardust landed safely in January 2006. The spacecraft did exactly what its hardware told it to do. The hardware did exactly what the drawing told it to do. By the time Genesis ever reached the atmosphere, the failure had already happened. Years earlier on a page, when nobody thought